Dear children, welcome to this session on Chapter 16, Inheritance. Inheritance is one of the most important features of object-oriented programming. It is the process of creating a new class from an existing class. Reusability of code is the main advantage of inheritance. Suppose class person is an already existing class and classes student and teacher are created from class person. Then class person is called base class and the classes student and teacher are called derived classes. By the process of inheritance, the derived classes are power packed because they acquire the properties of the base class in addition to their own attributes and methods. What is a base class? The class from which the derived class is created is called base class. What are derived classes? The classes created from the base class are called derived classes. When a derived class inherits only from one base class, it is called single inheritance. Here, class student is derived from only one base class, class person. This type of inheritance is called single inheritance. When a derived class inherits from multiple base classes, it is called multiple inheritance. In this example, class teacher is inherited from class person and class employee. Class person and employee are the base classes and class teacher is the derived class. When a class is derived from a class which is a derived class, it is called multi-level inheritance. Here, class vehicle is a derived class of class machine and class car is a derived class of class vehicle which itself is a derived class. So, when a class is derived from a class which is itself a derived class, it is called multi-level inheritance. The transitive nature of inheritance is reflected by this form of inheritance. Class vehicle inherits properties of class machine, which in turn are inherited by class car. This is the meaning of transitive nature of inheritance. Class car is more power-packed because it has inherited functionality of class machine as well as class vehicle. When there is a combination of more than one type of inheritance, it is called hybrid inheritance. In this example, class test is inherited from class student and class result is inherited from class test and class sports. Class test is inherited from only one base class, class student. Here it is single inheritance. Class result is inherited from two base classes, class test and class sports. This is multiple inheritance. Therefore, in this example, there is a combination of more than one type of inheritance. Hence, this is an example for hybrid inheritance. When more than one derived class inherits from a single base class, it is called hierarchical inheritance. In this example, two derived classes inherit from single base class. This type of inheritance is called hierarchical inheritance. Single inheritance, multiple inheritance, multi-level inheritance, hybrid inheritance, hierarchical inheritance. These are the types of inheritance in C++. Next, let us see how to create a derived class from an existing base class. Here I have two classes, class person and class student. To create single inheritance from class person to class student, next to class student, you place a single colon followed by public and then person. By this syntax, class student becomes the derived class of class person, which is the base class. To define a derived class, first you have to write the keyword class followed by the derived class name and then a single colon. After the colon, visibility mode. Here I have given visibility mode as public. After the visibility mode, you have to write the name of the base class. The visibility mode can be protected or even private. If the visibility mode is private, you can omit this visibility mode because the default visibility mode is private. So when you do not mention visibility mode, the visibility mode is considered as private. In case of multiple inheritance, here I have two base classes, class person and class employee. So after the visibility mode, you have to mention the names of all the base classes separated by comma. Here the base classes are person and employee. So here I write person, comma, employee. Therefore, what are the points to be noted while deriving a new class? First, the keyword class is to be used. Second, the name of the derived class is to be given after the keyword class. Third, a single colon. Fourth, the type of derivation, namely private, protected or public. The type of derivation means visibility mode. Fifth, the names of all the base classes separated by comma. To learn more about inheritance, let us see an example. Class rectangle is the base class and class cuboid is the derived class. Which members of the base class are inherited by the derived class? Only the protected and public members of the base class are inherited by the derived class. Here, the protected and public members of the base class are accept and display. So, only these two member functions are inherited by the derived class cuboid. Here in the derived class, the type of derivation is private. That is, the visibility mode is private. The protected and public members of the base class become private members of the derived class. So these two member functions, accept and display, which are inherited by the derived class, they become private members of the derived class. That is, even though accept member function is under protected in the base class, when it is inherited, it becomes private because of the private visibility mode. Similarly, the display member function, which is public in the base class, is inherited as private in the derived class. So, the protected and public members of the base class become private members of the derived class. Here I have created an object of the derived class cuboid. Can this object C1 access the inherited member functions accept and display? This object C1 cannot access the inherited member functions accept and display because accept and display are inherited as private by the derived class. You have already learned that private members of a class can be accessed only within the class. That is, private members of a class cannot be accessed by objects of that class. What happens if the visibility mode is changed to protected? The protected and public members of the base class become protected members of the derived class. So, accept and display member functions are inherited as protected by the derived class. If the visibility mode is public, then the protected members of the base class become protected members of the derived class, and public members of the base class become public members of the derived class. This means accept member function which is protected is inherited as protected itself, and display member function which is public is inherited as public itself. Here in this base class rectangle there is a display function. Suppose the derived class cuboid also has a display function. When a derived class member function has the same name as that of its base class member function, the derived class member function shadows or hides the base class's inherited function. This is called overriding. The function called display within the class cuboid, that is within the derived class, will invoke this display function, that is the display function within the derived class. And the inherited display function of the base class is hidden. If the derived class wants to access the inherited display function, then the function call should be given like this: the name of the base class followed by the scope operator. Rectangle :display. This function call will invoke the inherited display function of the base class. The class name along with the scope operator is called as the membership label. Next, I will show you how constructors and destructors are executed in inheritance. During inheritance, constructors and destructors of the base class are not inherited to the derived class, but they are executed automatically. When I create an object of the derived class, here I have created an object B1 of the derived class B. The constructors are executed in the order of inheritance, that is from base constructor to derived. That is, as soon as I create an object of the derived class, the constructor of the base class first gets executed and then the constructor of the derived class. And when this object goes out of scope, the destructors are executed in the reverse order. That is, first the destructor of the derived class and then the destructor of the base class. Now look at this output. Constructor of class A, constructor of class B, destructor of class B, destructor of class A. From the output it is clear that the constructors are executed in the order of inheritance from class A to class B, and the destructors are executed in the reverse order from class B to class A. Let us now quickly review this session. Inheritance is the process of creating a new class from an existing class. There are 5 types of inheritance in C++. To create a derived class, first you have to write the keyword class followed by the derived class name, then a single colon, then the visibility mode, and at the end the names of the base classes separated by comma. When a member function in the base class and the derived class have same name, then to invoke the member function of the base class, you have to use the membership label in front of the function call. Constructors are executed in the order of inheritance and destructors are executed in the reverse order. That's all in this session. Thank you, children.